All right, I think we're going. Okay, so 2.6, this is going to be graphs of rational functions. So before we can get into actually drawing graphs of these things, which will be actually tomorrow that we're going to start doing that. But before we do that, we need to define what is a rational function for you guys. Okay, so let's start with something you're familiar with. What's a rational number? Mm-hmm. We did kind of talk about that when we talked about the rational root test, right? A rational number is a number that can be expressed as a fraction. So we often think of rational as kind of like the fancy word for fraction. Okay, so a rational function is going to look like a fraction then. And the way that it's set up is, if we call it r of x for rational, it's equal to a function, call it f of x, divided by another function, call it g of x, where f of x and g of x are polynomials. Okay, so that's why this section is included in Chapter 2, because Chapter 2 is everything polynomial. Okay, that's what we've been studying so far. And so a rational function then is one that's defined as a polynomial divided by a polynomial. Okay, and so those are going to those types of functions are going to have certain types of graphs that are going to look a certain way. But because of the nature of them, there are going to be some key components of those graphs, some properties and that sort of thing, that we can take a look at before we ever start to graph them. And the first thing we're going to talk about is something that we've discussed in the past, and that's vertical asymptotes. So in the past, what have we done to find vertical asymptotes? Yeah. Right. So that's where g of x equals 0. Okay, so we're going to be looking for those. We'll also be looking for horizontal asymptotes. Okay, so we talked about this in Chapter 1. Let's see what we remember. How did we find horizontal asymptotes? Yeah, go ahead. It's based on the degree of those two functions. Okay, so there's kind of a lengthier answer to this. We've discussed this before, but I'm going to write it out again just so we have it in front of us. So if the degree of f of x is more than g of x, what happens in that instance? Okay. Think about a horizontal asymptote essentially is talking about as x gets really, really large, what's happening to the value of the entire function. We're talking fractions now, okay? So if the degree of the top of the fraction, so we have a bigger number, essentially, as we go out, on the top of the fraction as compared to the bottom, okay? What happens to that number overall? if the numerator is larger than the denominator and continues to grow larger than the denominator. What's happening to the value of that function, or that value of that number? Yeah. Exactly. If your numerator is growing more quickly than your denominator, wouldn't that thing just take off? Right? It just keep getting bigger and bigger and bigger and bigger, right? So there is no horizontal asymptote then. That limit goes to infinity. So in this case, we would say none. Okay. So if it's the other way around, if the degree of g of x is more than f of x, so now we've got the denominator is getting way bigger than the numerator. Yes? Has to be 0, right. Think about that. If you have fractions where the denominator continues to get really, really big and the numerator not as big, you're making smaller and smaller and smaller fractions, right? And so that's going to level off at 0 then. So that's why this one comes out to y equals 0 is that asymptote. All right, and then there's the last case where what if it's the same? What if they have the same degree? So then they're kind of essentially growing at the same rate. But we talked about how the leading term of a polynomial is really the only part of the polynomial that makes a difference when you have really large x values, right? You guys remember that part of our little polynomial investigation that we did, right? Only that leading term really makes a difference for really large values of x, which is what we're kind of talking about right here, right? So if I have some polynomial, let's say like 3x to the 4th minus 2x to the 3rd plus x squared plus 1 over some other x to the 4th minus x squared plus 5 or whatever, okay? So in this particular rational function, okay, got a polynomial over a polynomial, as x gets really, really large, all of this and all of this doesn't matter. Only those two leading terms matter. So what's going to happen is determined by this. 3x to the 4th divided by x to the 4th. And what does that simplify to? Which is 3, right? So my horizontal asymptote there should be 3, because it's going to get closer and closer to 3 based on that. So, same degree, this is why we always say divide the leading coefficient for that particular reason right there, okay? Now that you have a little bit more polynomial theory under your belts, that should make a little bit more sense. Okay, so that's how we're going to go searching for horizontal asymptotes, okay, comparing the degree of one versus the other. The other two things we're going to look at that we want to know about these graphs before we can start to plot them are x and y intercepts. So, and we've done a bit of both of those. All right, so an x-intercept. So let's go back to our rational function here, f of x over g of x. X-intercepts are places where this entire function is equal to 0. That's what we've been doing, right, with polynomials. Set it equal to 0, try to solve it, and usually what we do to solve it is to factor it or something like that. Well, if I've got an f of x over g of x equal to 0, does it make sense that really the only thing we have to look at is where f of x is equal to 0? Because what's 0 divided by anything? 0. So if I want this entire function, f of x over g of x, to equal 0, as long as I can find places where f of x is equal to 0, I've done that. The denominator plays no role whatsoever in that. Does that make sense? Okay. So because 0 divided by anything is still 0, I just want f of x to be 0, and I've done it. So to find x-intercepts, that's where f of x equals 0. That's it. And then we are also going to be interested in finding what is the y-intercept of one of these. That's going to help us kind of put things together. Think of any function in the world. If you want to find a y-intercept, what has to be true about x at a y-intercept? Has to be 0, right? So what do you suppose is the process for finding a y-intercept then? Exactly. You plug in x equals 0. If x is 0, I have a y-intercept. Okay, so put 1 in there and see what happens. Okay, so those 4 pieces of information are going to be kind of our focus for today. If I give you a rational function, can you do these 4 things for me? Can you find vertical and horizontal asymptotes? And can you find x and y intercepts? And then tomorrow what we'll do is, once we have that information, then we can start to piece together what the graph looks like and kind of start to do some of these graphs by hand. All right, so let's give it a try.